Hi everybody, this video is still in lesson 7.2. This is just concept 3 of 7.2. Concept 3 is rationalizing the denominator. What does that mean? Well, what's a rational number? Rational numbers mean they are fractional. They can be expressed as a fraction like 1/2 or -7/1. Irrational numbers cannot be expressed as fractions, for instance, pi or radical 2. So when we say rationalize the denominator, what we're talking about is you cannot have any radicals in the denominator. Well, what if you do? Well, if you do, you have to get rid of them. So how do you get rid of them? Well, you might have remembered this from previous years. And the way you get rid of them is you multiply it times whatever radical is there. Now you have to do it in the numerator and the denominator because that would be 1, and you can multiply times 1. And now what we get is when we multiply on the numerator, we get the square root of 3xy. And in the denominator, we get the square root of 9x squared, which is just 3x. And that was the whole point. We now do not have any radicals in the denominator. So that hopefully is something you've learned before. What if it's a cube root? Well, if it's a cube root, you actually have to have 3 of them because that's how cubes work, right? Because that's why it's cubed. So you have to have 3 of them all together. So I'm going to write it out this way. And so what do we have? Well, in the numerator, we have a cube root. They're all the same root, so we can multiply them. 3 times 2 times 2 is 12. And we have x to the second, and we have y. In the denominator, we have 3 of them, and they're all the same thing, so that's just 2x. And that's how you simplify a denominator with a cube in it. What if it has this? Well, do you remember a while ago that we have talked about this phrase conjugates before? And so we're going to use the conjugate, and that is, in this case, 14 plus 2. And then we have to do that also in the numerator. So in the numerator, we're now going to distribute this, and we get 5 radical 14 plus 10. And in the denominator, radical 14 times radical 14 is 14. And then we have a positive 2 radical 14 and a minus 2 radical 14. That adds up to be 0. And we have a negative 2 times 2, that is a minus 4. So we have 5 radical 14. 5 radical 14 plus 10 over 10. Now that can also be simplified. We can factor out a GCF of 5. So if we factor out a GCF of 5, we have radical 14 plus 2 over 2. And that's our most simplified version. Okay, this also applies to 4th roots, 5th roots, whatever. I'm going to show you a little bit different way. So like on number 2, I said you have to have 3 of them. You do. But on number 4, notice how there's an x squared. So we're like already halfway there. Let me show you what I mean. What I mean is, let's put a 4th root, and we need 4 3s. We already have 1. Now let's do 1, 2, 3. Now we have 4, because we had a 1 here, 2, 3, 4. We have x squared. We need 2 more x's. I'll just call it x squared. And so that's going to be multiplied on the numerator and denominator. Okay, so in the denominator, we have 3 times 3 times 3. That's 4 of them. That means the root and the power cancel each other out. And we have x to the 4th, and we're taking the 4th root of that. So we have x squared, or just x. In the numerator, they're all the same root, so we can multiply them. 2 times 3 times 3 times 3. Well, 3 times 3 times 3 is 27 times 2 is 54. And we have 3x to the 3rd. That cannot be simplified any farther. That is our answer here. On the very last problem here, when you have a square or a root like that that covers the whole thing, you can break it up. And I want to because I don't really care about rationalizing the numerator. I just have to rationalize the denominator. So I need to pay attention to the denominator. I have a 3rd root. I have 1 4 here. I need 2 more to get a total of 3. I have 1 b here, or excuse me, 2 b's. I just need 1 more. And I have 1 c here, so I need 2 more. And I need to multiply that on the top also. Getting kind of messy, sorry. So in my numerator, they're both the 3rd root, so I can multiply them together. 3 times 4 times 4 is 48. And then I have an a, I have a b, and I have a c squared. In the denominator, I have the 3rd root, and I have 3 4s, so I just have a 4. I have b to the third, but it's a third root. And I have c to the third, and it's a third root. So there's my final answer. It has been rationalized. It no longer has a radical in the denominator.